Hello everyone, this is Mike Bartles from HEC. Within this presentation, I'm going to introduce an analysis that we completed a few years ago, which developed Clark unihydrograph parameter regression equations for the entire state of California. This video is part 1 within a series of videos devoted to this analysis. This presentation builds upon previous lectures devoted to simple and multiple linear regression. You should notice several of the tools and techniques that were discussed in those lectures being applied here. As an overview, I'll present some background information on the agreement that led to the study, some of the key players within the study, the Clark unihydrograph method itself, and the study goals and steps. Now, if you know which dam this is, or more specifically which spillway this is, please write it in the comments. Now for some background information on our partner in this effort. The California Department of Water Resources Division of Safety of Dams, or DSOD, provides design, construction, and maintenance oversight for more than 1,200 dams throughout the state of California. Engineers that work for DSOD perform a multitude of services related to dam safety, including hydrologic, hydraulic, and geotechnical evaluations. Their H&H analyses typically utilize HEC tools like HEC HMS, HEC ResSim, and HEC Res. In 2019, HEC and DSOD entered into a memorandum of agreement to provide training and support. Specifically, DSOD requested assistance from HEC regarding design storm precipitation values, snowmelt modeling, development of unihydrograph parameters, loss rates, and other hydrologic modeling parameters, and provide guidance on the adjustment of Clark unihydrograph parameters when simulating extreme floods. The rest of this presentation is going to focus on a specific task that was part of the 2019 agreement. Develop tools and techniques that can be used to predict Clark unihydrograph parameters for DSOD's use in dam safety evaluations. Before we talk about the regression equation analysis, let's talk about the Clark unihydrograph method. Clark developed this method in the 1940s by representing two critical processes, that of translation and attenuation. Translation is the movement of excess precipitation to the watershed outlet in response to gravity. Translation in the Clark method is modeled using a time area curve, and the critical parameter to estimating translation is called the time of concentration. The second process is attenuation, which is the reduction of the discharge magnitude due to frictional forces and/or storage within the channel or basin that resist flow. The attenuation effects are modeled using a linear reservoir, and the parameter that controls attenuation is called the storage coefficient. The Clark unihydrograph method is the most widely used transform method in the world. It's been around for over 80 years now, and engineers continue to use it in thousands upon thousands of individual analyses each year. For more information on this method, check out the link here for a detailed video explaining its derivation. Now for some specifics related to the unihydrograph parameter regression analysis. DSOD required methods to estimate Clark and modified Clark unihydrograph parameters throughout the state of California for use within their hydrologic modeling applications. Numerous studies have shown that relations between synthetic unihydrograph parameters, like the Clark parameters, and watershed characteristics, like longest flow path, can be developed and successfully used to predict parameters for independent watersheds. And through the use of these equations, synthetic unihydrograph parameters can be derived for independent watersheds as long as the watershed characteristics are hydrologically similar to the watersheds for which the relation was developed. Hydrologic similarity includes similarity in topography, geomorphology, soil types, land cover, land use, and climate, amongst others. Now, these images shown here are historical examples of such regression equations which were developed to predict Snyder unihydrograph parameters within the Tulsa and Fort Worth USACE districts. Here's the general outline of the steps that were used within this analysis. 1. Select locations for use. 2. Build HEC HMS models for each location. 3. Extract physical characteristics for each location. 4. Calibrate each HEC HMS model to a representative storm event. 5. Extract and organize Clark parameters from each calibrated HEC HMS model. 6. Parameterize regression equations using the Clark parameters and watershed characteristics. 7. Validate the regression equations. And 8. Develop methods to quantify uncertainty in the regression equations themselves. In this video, I introduced the Clark unihydrograph parameter regression equation study that HEC recently completed for the state of California. In subsequent videos, I'll talk more about the HMS modeling and regression equation development that was completed as part of this analysis. Thanks for watching. I'll see you in the next one.